I'm sure when I'm done uploading all these videos, I'll figure out how to edit them so that I can actually not have to do 6 takes on the same thing. But until that time, we're going to go ahead with Chapter 17, Objective 3, the Nash Equilibrium and Prisoner's Dilemma. So in this particular objective, we're going to show you how to set up a payoff matrix, how to determine if there's a dominant strategy. And a dominant strategy is the strategy which is best, the best outcome, maximizes utility regardless of the other person's decision. And then through that, we're going to learn, if we have a dominant strategy, how to calculate the Nash equilibrium. If we don't have a dominant strategy, we're going to take a look at another method and determine how to calculate the Nash equilibrium. So without further ado, and getting in deeper to game theory, and how people behave strategically, let's go ahead and get at it. Okay, I'm sharing my screen with you. So again, what we're looking at here is determining the dominant strategy, using a prisoner's dilemma. So here we're looking at game theory. And game theory is the idea that there is a dominant strategy based upon 2 players. So if you've ever played a game where you want control of the board, maybe what you do is dependent on what someone else does. Chess is a great example, even checkers to some extent as well. In a prisoner's dilemma, we set up a game, and then we use the principles of a dominant strategy to come up with what's the best outcome for each person, regardless of what the other one does. Then we put that idea together and we say where we have an intersection of individual dominant strategies, that is the Nash equilibrium. So let's go ahead and do this and hope we get through it this time. So here, police have caught Bonnie and Clyde, 2 suspected bank robbers, but they only have enough evidence to implicate one of them or both of them for a year. So if you've ever watched any crime drama, you know, the first thing they're going to do is divide and conquer, put them in separate rooms, right? We're going to offer them a deal. So the DA comes in and says, if you confess and implicate your partner, you get to go free. That's a pretty big incentive, right? If you remain silent, but your partner implicates you, then you're going to get 20 years. If you both remain silent, then you're both going to get, if you both confess, then you'll both get 8 years. If you both remain silent, you both get nothing. But how much do you trust the other person in this scenario? So let's design a payoff matrix to see how we can get to an individual dominant strategy and how we can get to a Nash equilibrium. So Bonnie's decision, she has 2 possible outcomes. Her 2 decisions, known with probability, are she can either confess, decision A, or she can remain silent. Likewise, Clyde decisions will be in the yellow. Bonnie's are here in the green. Clyde can either confess or he can remain silent. Now, what we're going to do is take all the outcomes that were identified in the problem and fill them in this payoff matrix. So if Bonnie confesses, right, and Clyde confesses, so if Bonnie confesses, she will go free. If she remains silent, she might get 20 years, right? I should say if she confesses, she gets 8 years, okay? If she confesses and Clyde confesses, they both get 8 years. If she remains silent, she gets 20. If she remains silent and Clyde remains silent, she gets 0. So let's go ahead and fill these out, and I think it'll make a little more sense once I put these in. So if Clyde confesses, so we have Clyde confessing and Bonnie remaining silent. If Clyde confesses and implicates her, right? Then she gets 8 years. Now, the first thing I want to do is I want to represent this as how many years out of your life. So a -8 and a -20. If we take a look at this, we can say, well, okay, if, and again, I'm kind of switching thoughts here. If Clyde's decision to remain silent, Bonnie goes free, no years, or Bonnie gets 1 year, okay? Now, in Bonnie's instance, if she confesses and Clyde confesses, she gets 8 years because Bonnie implicated him. Okay. And again, we're going to treat this as a -8 and a -20. If Bonnie remains silent and Clyde confesses, then Clyde goes free. If they both remain silent, they get a year out of their life. Okay. So to take a look at how this would work, the first thing I want to do is to let's look at Clyde first, okay? So let's look at Clyde confessing. When Clyde confesses, he can either get -8 years or -0. So the first thing I'm going to do here is to add those two together. So that's a -8. Okay, Clyde can remain silent. If Clyde remains silent, he can either get -21 years or -1 year. So I'm going to add those two together for Clyde, and I get a -21. Well, -8 is better than -21, right? I'd rather spend 8 years than 21 because it's on this top row. Clyde's dominant strategy will be to confess. Now let's look at Bonnie's. Okay, and again, I'll just circle now that we've done Clyde's. Walk through this one. And again, you can rewind this a couple times if it doesn't make sense to you. So Bonnie's decision, she can either get -8 years or none. So I would pick add the two together, -8 and 0, that's -8 for that cell, if you will. -20 and -21, add the two together, and you get -21. Now, which would, enough, my TA. So which would you rather have, -8 or -21? She would rather have -8. So that leads her to the dominant strategy of confess. So Bonnie's decision will be to confess. Clyde's decision will be to confess. Because we have these as confess, 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 and they're both in the same cell. This will not only be our dominant strategy, but it will also be our Nash equilibrium. Okay. Let's go ahead and erase all that. And let's go ahead and talk through the next one. Hopefully I won't get as much help from my TA. Okay, so confessing is the dominant strategy for each player. And again, how do we know that? So I'm going to just do this a little more quickly this time. Again, -8, -20, -0, -1. So for Bonnie, we're going to look at it in terms of our columns in the green. -8 and -0 makes a -8. -20 and -1 makes a negative 21. Whoops, 21. So I know that her dominant strategy has to be on this side, on the left-hand side, which is confess. Now we look at it for Clyde, and I'll do that in blue. So in Clyde's instance, we have a negative 8 and a negative 0. We have a negative 20 and a negative 1. Negative 20 and negative 1 is negative 21. Negative 0 and negative 8 is negative 8. Negative 8 is better, so I know it's going to be the top. So his strategy is also to confess. Because they intersect and confess, that is also the Nash equilibrium. Okay. So each would get 8 years in prison. However, governing dynamics, if they would have stuck to the trusting of the deal and both remained silent, they would have been better off. Okay, so cartels, we saw that already in terms of, looking at T-Mobile and Verizon. When T-Mobile and Verizon cooperated and stuck to the deal, their overall profitability was higher. We can look at that in terms of a payoff matrix. So here's our payoff matrix using the example that we started in the previous objective. Here, again, what are the two objectives, the two outcomes? They can either produce 30, T-Mobile, or 40. Verizon can either produce 30 or 40. Just simply looking at this is a positive thing now. So what we're going to do is to look at Verizon first. So we have 900. Oops, I'm sorry, that's wrong. We have 900 and 750, which ends up being 1650. All right, adding those two together. Then we take a look at 1,000 and 800. Add those two together, we get 1,800. So Verizon's dominant strategy is to produce at a quantity of 40. Why? Because 1,800 is larger than 1,650. Okay, let's go ahead and look at the let's go ahead and look at T-Mobile. In T-Mobile, now they can either produce 30 or 40. So now we're looking at T-Mobile. We have 900 plus 750, and that's going to be 1,650. Okay. We have 1,000 and we have 800. Add those two together, we get 1,800. 1,800 is better than 1,650. So T-Mobile's dominant strategy is also 40. Because the dominant strategies fall in the same cell, meaning 40 and 40, this will be 40 and 40. The quantity of 40 will be our Nash equilibrium. This works really well if you're looking for the Nash equilibrium through the dominant strategy. Now let's take a look at another example. So here we have American Airlines and United Airlines. We can cut fares by 50% or leave the fares alone. If they both cut fares, each airline's profit will be $400 million. So that would be two cells, both cut fares for each one. Neither cuts fares, so there's our two decisions. So we have cut fares and then not cut fares for American Airlines would be 400 million. Cut fares for United Airlines would be, let's see, cut fares for 400 million. Not cut fares, American Airlines would be 600, and United Airlines 600. And then we would put this information into our payoff matrix. If only one airline cuts its fares, its profits 800. If the other airline cuts its profits, it's 200 million. So draw a payoff matrix, find the Nash equilibrium. Here is our payoff matrix. Again, start with what are the two decisions that they can make? Cut fares or don't cut fares. Those become your row headings and your column headings. Okay. So we have we have each player. So player one, player two. Then our row headings are their two choices, but player two's two choices. The column headings are players one's two choices, where the two intersect. So if American Airlines cuts fares and United cuts fares, 400 million, 400 million. Don't cut fares, but the other cuts fares. That's how you kind of, that's how you create these payoff matrices. Okay, so let's go ahead and look at the strategies. Again, this is a good thing because we're talking about profitability. So let's start here with player two, United Airlines. So we have 400 and 200. That's wrong. Let's do it this way. There we go. So United Airlines, we have 400 million and 800 million. That's 1,200 million. We have 200 million and 600 million. That's 800 million. Which is better? Definitely 1,200 is better than 800. So cut fares is going to be the dominant strategy for United Airlines. Now we'll look at American Airlines. Let me do it in a different color. That's good. Okay, American Airlines, we have 400 million and 800 million. Add the two together, we get 1,200 million. Don't cut fares, 200 million, 600 million, 800 million. Okay, which do I want more? I'd much rather have 1,200 million. That leads us over to this column. So therefore, their dominant strategy is as well to cut fares. So here, our dominant strategy, which strategy or decision is the best, regardless of what the other person chooses, it's to cut fares for American Airlines and to cut fares for United Airlines. Because both of these are the same, that is also our Nash equilibrium. Okay, hopefully that makes a little bit more sense. The more you do it, I think the clearer it becomes. Cool. So both firms cut fares. Okay, the other thing that I think might be beneficial to show you is what if there isn't a dominant strategy? And sometimes that does happen. So let me go back to this American Airlines example and change it up just a little bit. Let's say instead of 400 million here, I'm going to change this out. And I'm going to say, let's see, I need to look at this overall to see how I can do it. 2. No, let's not do 2. Let's do, yeah, let's do it that way. Okay, 200 million, which I'm going to move this one now to 200 million. Okay. So in American Airlines, now we have 200 million and 200 million. So I'm looking at United Airlines cutting fares, 200 million and